I'm Zhang. I'm from Taiwan Minji University of Technology. The topic of today's speech is effect of oxygen concentration on the characteristics of the recycled carbon fiber from waste using microwave-induced pyrolysis. And professor is Wenhui Guan. My presentation consists of the following parts. First is introduction, and the second is methodology. And then is results and discussion. And the final is conclusions. First, let's talk about carbon fiber. There are three kinds of carbon fiber raw materials on the market. About 90% are made of polyacrylonitrile, which means PAN. And the remaining 10% are made of rayon or asphalt. Carbon fiber has excellent materials properties, such as high strength, high modulus, lightweight, corrosion resistance, and high temperature resistance. So there are two processes to be polymerized from PAN to carbon fiber. We can see this one, oxidation, and the next one is carbonization. The oxidation process is affected by changes in the tension of the fiber. Changes in temperature and the environment of oxygen. After the oxidation process, the PAN-based fiber is heat treated in an inert gas at a temperature as high as 1500 degrees Celsius. Except for the carbon elements, almost all other elements are removed in the form of byproducts during the heat treatment to form a graphite-like structure. And let's move on to carbon fiber composite manufacturing process. A material composite of two or more materials is called a composite materials. Carbon fiber composites are made by weaving carbon fibers into carbon fiber cloth and then coating thermoplastics. That is epoxy resin, and then becoming prepreg after chemical reaction. By heating the mold to form a composite material, then the step of coating and assembling can become the current carbon fiber product. Here you can see the brief process of carbon fiber synthesis from PAN to the finished product. This section shows from PAN to the carbon fiber for the reinforcement of the original silk. And this part shows the combination of carbon fiber and epoxy resin to make carbon fiber products, such as woven clothes or prepreg or carbon fiber step fiber. And this section, this part shows through chemical reactions such as hardening and then molding with mold, it can become a carbon fiber composite materials or carbon fiber parts. And fixation, we can see because of its high strength and lightweight and wear resistance, carbon fiber composite materials have been used in many industries, such as aviation, automobiles, ships, sports, and leisures. This data shows that in the past, in 2015, the global carbon fiber demand was about 70,000 tons. We can see from this distribution that in 2015, 70,000 tons of demand. Industry application accounting for a higher proportion. And then we can look at this timetable. It shows the application and future development of carbon fiber composite materials. We can see that construction and medical application have begun in late 2020. At the same time, it has begun to explore the recycling of carbon fiber composite materials. Whether it is an airplane or a car, these manufacturers have been pursuing the reduction of the weight of the fuselage. Due to the light weight and high strength of carbon fiber composite materials, they have been more and more widely used in these industries. It is predicted that in 2025, it will continue to be used in large quantities. So, what is more important in the future is how to regenerate applications. Based on the previous discussions, the purpose of this experiment is to make the carbon fiber composite material sustainable. We collect the waste carbon fiber composite materials after the experiment, return it to original silk, and make it again. And this is my experimental framework. We explore the carbon fiber industrial and many of industry source and the principles and application of microwave. We choose to mix oxygen and nitrogen to test the effect of microwave process pyrolysis on the recovery of waste carbon fiber composites. Pyrolysis is a common method of recycling carbon fiber composites. Heat treatment in air can remove carbonized residues, but the fiber strength may be damaged by oxidation. So we explore the effect of oxidation. We explore the effect of oxygen concentration on the characteristics of waste carbon fiber. This is a methodology. Let's talk about microwave principle. Microwave is an electromagnetic electromagnetic wave with a wavelength ranging from 1 to 1000 millimeter and a frequency is from 0.3 to 300 gigahertz between infrared and radio waves. Microwave have three different characteristics or substance of different materials, namely absorption, penetration, and reflection. The carbon fiber in the carbon fiber composite materials used in these experiments has good conductivity, so it can quickly absorb microwave energy.
อันนี้คือ account ที่
and then this is my experiment equipment. Power is supplied by the power supplier and microwave energy with a frequency of 24.5 gigahertz emitted through the magnetron. The microwave is incident on the crucible and the sample by unidirectional polymerization in radiation. The gas will first be adjusted by the mass flow meter to the required proportion, mixed through the glass mixing tank, and then enter the systems. This is the result and discussion. This table shows the proportion parameters I used throughout the experiment. The wet carbon fiber composite materials collected in these experiments include bicycle parts, bicycle insoles, and a waste pipe material. And 3 samples were analyzed by TGA before the experiment. Choose to use air for analysis. From the temperature, it is possible to infer the substance that may be those in each temperature range. The right table is sorted out by calculations. So for insoles, it can be seen that the components that use carbon fiber account for the majority. And for bicycle parts, most of weight is lost between 350 to 450 degrees, and it is inferred that the recent was removed in this range. For waste fittings, an additional temperature range for weight loss, we can find that it may be the unevenness of the sample. So the data clearly shows the uneven distribution of the carbon fiber proportion. The picture on the left is the comparison before and after the experiment. The treated sample were subjected to a stretching test. In terms of insoles, we can see that the increase in oxidation concentration will increase the strength of the fiber. In terms of bicycle fittings, the fiber strength didn't seem to change much. So I guess the fiber strength was destroyed during the experiment. It can be things like when the oxygen concentration is on 15% and 25%, it has better strength. The representative may be we can reduce the oxygen concentration to test the fiber strength. These are 3 points of my experiments. The first one is according to the current experiments, it can be found that the carrier gas was with different oxygen concentration obviously affects the carbon fiber composite materials. And the second one is at the fixed microwave power and time, pyrolysis condition with an oxygen content of 15% to 25% in the carrier gas can produce relatively high tensile strength of regenerated carbon fiber. And the final, the optimal oxygen concentration in the carrier gas can effectively gasify the explosive resin, but it will not damage the carbon fiber structure. Thanks for listening. Thank you.